Alright guys, welcome to this page of the notes, and let's go ahead and sort of dive into this idea of completing the square. Now, before I show you how to complete the square, let's talk about why we have this as one of our methods for factoring. Hopefully what you're thinking as you sort of reflect on the problems that we just got done doing on the previous pages here of this note set was, man, those were really easy, right? And you're right. They are really easy. This idea of having a perfect square trinomial, being able to factor the perfect square trinomial and using the square root property to solve is certainly very, very easy as far as some of the algebra that we've done so far this year. And so the idea here behind the completing the square method is to turn all of our quadratics into perfect square trinomials, so that what we did on the previous page of the notes here when solving, we can do for every problem. The sort of the complication that we run into is that not all of the problems that we're going to come across are already perfect squares. Let me show you. This one right here is just like the problems we've done on the previous page of the notes. I have a trinomial. 25 is a perfect square. So I know right away that I could write this guy as two binomials and use the property that we used on the previous page of the notes to solve this guy. Easy peasy. Really, I know, you guys like it. You're thinking right now, this is awesome. I love this method. So do I. But here's where we run into a problem. Sometimes you'll be given a quadratic where I have a trinomial. But 22 is not a perfect square. Hence the name of the method, completing the square. We will get rid of the number that we don't want, the 22. It's not a perfect square, so we'll get rid of it. And we will replace it with a perfect square so that I can then do what we did on the previous page of the notes. Complete the square, factor it as a perfect square trinomial, and use the square root property to solve. So what we're going to be doing is using the square root property when it is a perfect square. And when it's not a perfect square, we will use the square or completing the square method to make it a perfect square. I know. I'm excited too. I can't wait to jump into this. So here we go. Here's the way it's going to work. Completing the square. You've been waiting for it. Now it's time. The way that you complete the square is that this value right here, right, when the quadratic is in standard form, ax squared plus bx plus c, the value of c, this guy right here, that c, must be equal to b divided by 2 squared, which I almost will never write it that way. You guys should know, right, properties of exponents. Whenever you have whenever you have a fraction, that quantity, that fraction is squared. You simply square the numerator, square the denominator. And so a b divided by 2 squared would be a b squared divided by 4. I will almost always use this one right here. This is, oh, sorry. Oh, yuck. I had my highlighter. I apologize. I will almost always write it like this. In fact, I can't ever think of a time when I would do the b divided by 2 squared, since this is b squared over 4, that's just where we're headed. So here's what we need. I need this value of c to be equal to whatever b is squared divided by 4. Let me show you. In order for this guy to be a perfect square trinomial, which we already know it is, but let me show you why. C needs to be equal to b squared over 4. Okay, well, my b in this case is a 10. So I would have a 10 squared divided by 4. Well, 10 squared is 100 divided by 4. And 100 divided by 4 is 25. And that is exactly what I have in my position for C. It's a 25, which is why this is a perfect square trinomial. I can then factor it into two binomials and then use the square root property, just like we did in the previous page of the notes on those super easy problems. This one would be no different. So yes, this one is a perfect square trinomial. This one, the ones that are going to cause us a little bit of an issue. Well, I need c to be equal to a b squared over 4. Well, my b in this case is an 8. Divided by 4. Well, 8 squared, of course, is 64. 64 divided by 4 would be a 16. So in order for this to be a perfect square trinomial, this guy right here would have to be a 16. And it isn't. It's a 22. That is what we're going to be doing for the rest of this set of notes. We're going to be dealing with problems like this, where c is not what I need it to be. So we're going to get rid of whatever you've been given. We're going to put in what we need and force these quadratics to be perfect square trinomials so that we can then factor it the way that we did the ones on the previous page of the notes, using the square root property. Oh yeah, that's the way this is going to go. I love it. I'm so excited. So here we go. Before we jump into doing some of those more complicated problems, though, I want to give you guys a little bit of practice using this b squared over 4. So here's what I'd like you to do. I've given you this guy right here, x squared minus 6x, and I'd like you to complete the square on this guy. Right now, I need you to give me the value of c, right? I apologize, hold up. ax squared plus bx plus c. Well, I've already given you the x squared and the minus 6x. What I'm asking you to do is find the value of c that makes it a perfect square trinomial. And we just talked about how you do that. You're going to add a b squared over 4. All right. I think at this point you guys will probably be pretty comfortable doing this in your head. Your b is a negative 6. So I'm going to do a negative 6 squared, which would be a positive 36. 36 divided by 4 should be a 9. So I need this to be a 9. And now I have a perfect square trinomial. Since 9 is a perfect square, I need two numbers that multiply to 9, sum to a negative 6. And because this is a perfect square, these two numbers have to be the exact same number. Minus 3, x minus 3 squared. Right, you see the way this works? What we're doing is you're going to be taking quadratics, completing the square, right, so that you can write them as a quantity squared and then use the square root property to solve. Right, let's practice a little bit more. Let's see what we've got here on the next page of the notes. Give you guys a little bit more practice here with completing the square before we jump into a couple of the trickier problems. So here we go. What I've done is I've given you this quadratic, x squared plus 16x plus c, and I'm asking you, right, to find the value of c that makes this a perfect square, and then I want you to write it as a perfect square trinomial. Piece of cake, here we go. I need c to be equal to b squared over 4. Well, I think you guys, again, like I said, can probably do these in your head. So we're going to do my b is a 16. So I would have to do a 16 squared, which should be, let's see here, I got a calculator right here. 16 times 16. 256. So I'm going to wind up with 256 divided by 4, which comes out to be 64. So that means then that I have x squared plus 16x plus 64. Okay, well, that's a perfect square. Leading coefficient is 1, so it's going to be x and x. I need two numbers that multiply to 64, sum to 16, and because 64 is a perfect square, they have to be the same number. Yeah, 8 and 8. Guys, I got a ton of example problems for you here, and I think you're probably going to be okay with the way that these go. So jump ahead if you'd like to. Give these a shot, and then come on back, check your answers with mine when you get done. Here we go. I need to find the value of c. So c needs to be equal to b squared over 4. Let's see here. We're going to have a negative 14 squared divided by 4. So we're going to have negative 14 squared divided by 4, which put into your calculator should come out to be 49. Which means I'm going to have x squared minus 14x plus 49. Yeah, 49 is a perfect square, so you're going to wind up with a negative 7 minus 7, and that's going to be x minus 7 squared. It's actually would be a good time to note, you will always be adding b squared over 4, and here's the reason why. Because you square b, it doesn't matter if b is a positive or a negative number. When you square a number, it will always be positive, right? A positive times a positive is positive, and a negative times a negative is positive. So this will always come out to be a positive number. In fact, if you ever do b squared over 4 and you get a negative number, you messed up, fix it, and you will always be adding a b squared over 4. It should always come out to be a positive number. So here we go. Let's try a couple more. Let's see here. In this one, I got an 8. So this is going to be c is equal to b squared over 4. Let's see. 8 squared is going to be 64 divided by 4, which is going to be 16. So I wind up with x squared plus 8x plus 16. Four and 4. Nice, guys. Well done. Good job. Gives me an x plus 4 squared. Ooh, awesome. Here we go. Slightly trickier. Now you've got a fraction. That's okay. Don't let it freak you out. Here's what we're going to do. Just show all your work. Don't fat finger something on your calculator, and you're going to be just fine. C is going to be equal to a b squared over 4. Well, my b is a negative 16 fifths. So I'm going to have a negative 16 fifths, which I will square. It's all over 4. Okay, so 16, we already did that one. It's 256. 5 squared would be a 25, and that's all divided by 4. And then here's the way it works. You could either do keep it, change it, flip the bottom, or you could just recognize that this is a mixed fraction, and the 25 just gets dropped into the bottom. And so you wind up with 256 over 100. Which of course reduces to 64/25. All right, that's the value of C. Here we go. Now, I know this one looks scarier than the other ones, but here's why you're going to love this method of factoring. You will love it. 64 is a perfect square, and 25 is a perfect square, and you know these two numbers have to be the same. So all you've got to do is what times what gets you 64, and below that, what times what gets you 25. Which couldn't be easier, and since this guy's negative, you know they both got to be negative. So it's got to be a minus 8/5 and a minus 8/5, right? Why? Well, a negative 8/5 times a negative 8/5. 8 times 8 is 64. 5 times 5 is 25. And then, of course, if you were to add those middle terms together, you would wind up with a negative 16/5, which I don't have to show you. Trust me, it's going to work out. That's the way these problems go. And since those are the same, you would write it as x minus 8/5. And I apologize, I should not have said trust me on it. Math works out. You don't have to trust me. Let me show you. Here's what we're going to do. X times x, x squared. I already showed you how negative 8/5 times negative 8/5 is going to be 64/25. Let's talk about those middle terms. X times a negative 8/5 would be a negative 8/5. Negative 8/5 times x would be a negative 8/5 x, right? So what you wind up with is minus 8/5 x minus 8/5 x, right? Those would be my middle terms. Well, they're fractions, so add them up. Remember to add and subtract fractions, you need a common denominator, which I already have. So it would just be a negative 8 minus 8, which is negative 16. And I apologize, I should not have said take my word for it. I will show you, trust me, I want you to know that it works. You don't just have to take my word for it. So anyway, here's what we wind up with. I know that these fractions, right, they look scary, but they're not. It's just as easy as the ones that we have been doing before. You're going to wind up with something that's perfect squares over here, and you just got to figure out what two numbers, right? You got to multiply together to get that guy. So let's go ahead and do another one. Looks like on this one I've got decimals, but what I'm going to do is, I'm going to turn that decimal into a fraction. So I'm going to do x squared. 1.8 is going to be 9/5. And I need to find the value of c that makes this a perfect square trinomial. So let's go ahead and do that. C is going to be equal to b squared over 4, which is going to be 9/5 squared over 4, which is going to be 81/25 over 4, which is going to be 81 over 100, which doesn't reduce. All right, cool. I need two binomials, and you guys know how it works at this point. Because 81 over 100, both of those are perfect squares. These two numbers have to be the same. They got to multiply to 81 over 100 and sum to a negative 9/5. Again, it's really easy. 81 is a perfect square, so it's got to be a 9 on the top, and 100 is a perfect square. It's got to be a 10 on the bottom. So minus 9/10 minus 9/10. And again, I know, you guys are looking at that and going, what the heck? How does that get me to 9/5? Let me show you. You FOIL this guy out, x times x gets you the x squared, negative 9/10 times a negative 9/10 gets you the 81 over 100. What we're interested in is that negative 9/5. Well, you're going to wind up with a negative 9/10 x minus 9/10 x in the middle, right? This is side work, right? I'm just showing you that this method works. It's just as easy as it looks like it is. And we add our fractions. But in order to add fractions, I got to have a common denominator. Well, my common denominator is going to be a 10. Negative 9 negative 9 plus a negative 9 would be a minus 18. And that reduces, right? I can pull a 2 out of both of those, and you wind up with your negative 9/5. And I apologize, I'm trying to squeeze in over here. Hopefully you can see that. I get my negative 9/5 x, which is my middle term. All right, guys, this works out. This method is fantastic. I love completing the square. And so what we're going to do now on the next page of the notes is look at some of those trickier ones where the value they give you is not the value you need, and how we're going to go about dealing with that particular issue. So head on over to the next page of the notes, and I'll see you guys there.